Hello YouTube, this is Frank, and this is December the 28th, 2021, and this is my 58th video and my 20th topical video. And the topic today is the high gas prices that we've seen lately, and I'm using linear regression to look at those prices. Now, on this channel, we do not do conspiracy theories. We go to our state flagship university to get more information. Now, the reference that I was using is David Lane, Introduction to Statistics, and the data from the Energy Information Agency. I did do a linear regression with Brent and regular gasoline. There's my equation from now I'm using dollars per gallon on all of my units, and the data they give the Brent is in dollars per barrel, so I convert dollars per barrel to dollars per gallon, and I am using the weekly data set, and my R squared was 0.903. So we get a good fit until a few months ago. Now I did plot the residuals with Brent, time, and on a QQ plot. The residuals on a linear regression, that should be linear on a QQ plot. Let me show you what I got. There's my Raspberry Pi that I'm using. And let's see here. Now there's my, I made a directory from my EI data. Now this is, if you go to the Energy Information website, they said use U.S. gasoline prices move with the Brent rather than West Texas. Brent is an international benchmark, and gasoline is a globally traded commodity. So they're saying you use Brent and with gasoline. So let's get over here, and I'll show you what I was looking at. Let me blow this up a little bit. So there was a good fit. Now this is the last 15 years of data from 2006 to the present. Downloaded that data this weekend, and we do have some extreme events. There's that in 2008, and there's another event, and then there's the extreme lows there that we saw from the COVID event. When lockdowns, there was the school closings, and the economy had a small recession, and the unemployment was 15%. The miles driven, if you look at the Federal Transportation site, you can see the miles driven during that time went down a good bit. But this is what I was seeing right here. Look, this is Brent is on the bottom. And then the observed gasoline price is the regular. And then our model, the model fits pretty good until a few months ago. And that's what I am looking at right here. Why is that? Why is that? The observed gasoline, why is it so much higher than the predicted? let's see here now. Let me close that. This is the reference that I was using, Introduction to Statistics, David Lane. And this is he released his statistics textbook into the public domain, so we can use that without limitation there. That's a good introduction to statistics. So let me show you what I've got here. This is my spreadsheet that I've already got everything solved. Let's see now. Let me go up here. This is started in January 2006. That's where my linear regression starts. There's Brent, dollars per gallon, and regular gasoline. And these are weekly prices here. These are weekly from the website. I plotted the residuals, and I'll show you my residuals. I plot Brent with the residuals, time with the residuals. There's my QQ plot with the residuals, and that should be a straight line. And this is my model. The date, Brent, regular gasoline, and there's the model. What the linear regression was modeling. So let's go down here. Here's my model. Brent, dollars per gallon, regular gasoline, and there's my model, linear regression, 0.88 times Brent plus 1.25, and there's my R squared. This is the residuals plotted with Brent. There's a cluster here and a cluster there. A cluster around $1.50 and in between $2.50 and $3. If we look at our graph over here, let's see here. There's a cluster of prices for Brent there, 2.5, and in between around 1.5, there's a cluster. So that's why I think that's the those are those clusters that I'm seeing right here. This is the residuals with time, and I really didn't expect to see any. I mean, they're highly correlated with time. And this is the QQ plot. The residuals on a QQ plot, they should be the residuals should be have a normal distribution, and that's pretty much a straight line there. So that's what I was. And that's the statistics that I was using for the linear model. Oops. And this is, I don't know why. I do not know why there's such a big gap right there in the recent months. So that's what I was looking at this weekend, or this holiday weekend. I was just curious about the gasoline prices, and I ran a linear regression on Brent, regular gasoline. Raspberry Pi is a little too slow to show the my step-by-step instructions on how I got here. But if you download the data, there's the data, weekly spot prices. Let's see, and then our weekly regular gasoline. Let's see here now. We put those side by side. Those are the weekly gasoline prices. Let's go down to the bottom. Down to the bottom on here. If we look at our prices, our dates, this is why I use AWK to merge these data sets. So there's the weekly data for the gasoline is on Monday, and the weekly prices for Brent is on Friday. So I use a AWK program to merge those data sets, and I merge the Mondays into the Fridays here. That's, let me see here now. We have kind of and this is my data set with the, I converted those dates. I converted the dates into numbers. These right here. And that's what these are, just the numbers for the dates. There's my Brent, and there's my regular gasoline. So that's what I've been doing over the weekend. There's my, let me just go back to my slide right there. I don't know why. You know, why is the observed gasoline price so much higher than I predicted? And you know, we see these extreme events, and I don't see, you know, the big gap that we see the last few months. So anyway, that's what I've been doing the last over the last few days, looking at observed Brent with observed gasoline. So thank you.